Welcome to qnawire.
All right, we can use Descartes' rule of signs to determine the possible number of positive zeros by sign changes. It changes from a positive to a negative term and then to a positive, so there could be two or none. For negative, think of negative x cubed minus 9 times negative x squared minus 25 times negative x plus 33. That'd be negative x cubed minus 9x squared plus 25x plus 33. So it's a negative, negative, positive, positive. So there's only one sign change, meaning there can only be one negative zero. That's Descartes' rule of signs. We could find, let's start with positive zeros. The least positive can be two of them. Let's just start testing that by the rational. Well, by the rational zero theorem, that's the factors of the leading coefficient, which are 1 and 33. Oh, and 11. Factors of the constant over the factors of the leading coefficient for all the possible rational zeros. So that would be positive and negative 1, 11, or 33 if we have them. So let's start testing them. Let's see if 1 is by synthetic division. We have coefficients 1, negative 9, negative 25, and 33. Drop down the 1, multiply, add to get negative 8, multiply, add, multiply, add. We get a 0. So 1 is a 0. We could check 11. That would be the next possible positive. And since 1 is a 0, we actually don't need, we can use the remaining quotient row to make it a little easier on ourselves. Drop down the 1, add to get 3, multiply to get 33, add to get 0. 11 is a 0 as well. And there can't be any more, so let's go negative. Let's see if negative 1 is a 0. Drop down the 1, multiply, add. Negative 1 is not a 0. Oh, shoot. I forgot 3. Positive and negative 3 could be here as well. Sorry about that. Didn't affect us in the positive. We found those really easy. But negative 3 would be the next possible negative 1. That didn't work, so back to 1 and 3. Drop down the 1, multiply, and add, and that's a 0 as well. So that would be our third and final